the radius of a spherical ball. So we have a spherical ball. You can think like a golf ball. Radius is increasing at a rate of 2 centimeters per minute. So radius dr over dt is 2 centimeters per minute. At what rate is the surface area? The surface area is increasing when the radius is this radius is increasing. So at the moment when the radius is 8 centimeters, at what rate is the surface area increasing? So radius and surface area, so there are two variables, so we need to write down the formula. And the surface area of a sphere is given by 4 pi r square. Okay, this formula. A lot of times this formula will be provided in the question. Now we differentiate both sides with respect to time. 4 pi is constant. Derivative of r square is 2r times dr over dt. So 2 and 4 pi means 8 pi. So 2r, I multiplied here, times dr over dt from the chain rule. Now plug in the given and find the unknown. So ds over dt is what? So 8 pi, r is 8, dr over dt is 2. So that's 8 times 8, 64 times 2, 128 and pi. So don't go for decimals, this is it. 128 pi. So area, surface area. So centimeter means centimeter square per minute. Okay, let's do number 8. Okay, here a plane flying horizontally at an altitude of 1 mile and a speed of 5 miles per hour passes directly over a radar station. Okay, here is radar station and plane is just flying over 1 mile above this one, and it's going at the rate of 500 mile per hour. That plane passes directly over a radar station, so somewhere like this. Find the rate at which the distance from the plane to the station. So plane is somewhere here and a station, so this distance, direct distance, is increasing when the plane is 2 miles away from the station. So suppose the plane is here, and when this distance is 2 miles, this distance is continuously changing. It is 1 mile, okay, it's continuously changing. Now when this distance is 2 miles, how fast? We need to find the rate of change of this distance, okay. Find the rate. Let's say this is g, so dg over dt. The rate of change of this distance is what? At the moment when this plane is 2 miles away from the station, so when g equals 2 miles. Okay, that's the case. Now we consider pretty much a right triangle, this right triangle, and we this is g, so let's say this is x, and this is the rate at which the airplane is flying, so this will be dx over dt. It's 500, and this is 1 mile, this is fixed. Okay, now this is a right triangle. Then we know a square plus b square equals c square. That means x square plus 1 square, which is 1, equals g square. So this is the relationship between these two variables. So we do this. Now find the derivatives of both sides. with respect to time. So derivative of x square is 2x times x prime means dx over dt, plus derivative of 1 square means 1, and derivative of a constant is 0. Here 2g dg over dt. Now let's plug in and find the unknown. So 2 times x, what is this distance? We don't know. Then we have to use this again to determine x. Okay, let's do over here x is squared plus 1 is squared is g squared. X is unknown. G is when g is 2. So when airplane is just 2 miles away from the radar station, so 2 squared 4, subtract 1 from both sides, 3, take a square root, so x is square root of 3. So this is square root of 3, dx over dt is 500 miles per hour, plus 0 does not count, 2 times g is 2 miles away, and dg over dt is what we are looking for. Okay, 2 times 2, 4, and we have something, divide both sides by 4. So 2 times root 3 times 500 divided by 4, 2 times 2 equals dg over dt. Now we can simplify the left hand side. 2 goes 250 times, so the final answer is dg over dt is 250 root 3. 250 root 3. Okay, it will be a decimal number. That's miles per hour, because this is the distance. So miles per hour. Okay, and this is separate. So this is final answer. And let's move to the last question of this page. Snowball. Snowball is again a kind of sphere. I mean, it's a sphere. Melts, so its surface area decreases. Okay, this surface area ds over dt decreases at a rate of 1 centimeter square per minute. So that's negative. Something decreasing means negative. Negative 1 centimeter square per minute. Find the rate at which the diameter decreases. Okay, diameter. So derivative of diameter, let me denote by d, uppercase D, because lowercase d is here. This is what? Rate of change of diameter when the diameter is 10 centimeter. At the moment when the diameter is 10 centimeters. Centimeter, so we don't have to worry about units. So we need to write down the surface area in terms of diameter, and that's pi d square. By the way, this formula will be provided a lot of times. So surface area is 4 pi r square or pi d square, because the diameter is 2 times r. Now let's plug in the given and find the unknown. Okay, hold on. We need to differentiate first. Find the derivatives of both sides with respect to time. And I'm using d as uppercase D. So ds over dt equals pi is pi, constant. So it's like x squared. So 2x, x prime. So derivative of diameter with respect to time. That is now ds over dt is negative 1 because it decreases. 2 pi times d is 10 and dd over dt. Now divide both sides by 2 pi 10, that's the 20 pi. So this dd over dt, rate of change of diameter is negative 1 over 20 pi. Okay, so diameter also decreases because we got negative at this rate. So its diameter is length, so only centimeter per minute. Okay, that's the final answer here. or this. So this negative means diameter decreases. Obviously, when snowball melts, surface area decreases, so diameter also decreases in this way. Final.